Okay guys, so today we're going to continue with the fraction review. It should go a little faster than yesterday. I realize that was like over a half hour lesson, but you know, a lot of the stuff that we're going to do here we already covered there, like the whole mixed number thing and reducing and that sort of stuff. So hopefully it just is more efficient of a video. It's not that I'm going to try to rush, I'll just try to be more efficient. So we will be looking at adding, subtracting fractions with the same denominator, which is super easy. That's going to take like a few seconds. Different denominator, that's probably something that you remember doing, you know, in your younger years that you really were not a fan of. We'll deal with mixed numbers again, which become improper fractions. And we need to talk about signs. This is algebra. You're expected to know, like the back of your hand, how positives and negatives work when you're adding or subtracting. Now I'm going to start focusing on just the signs, and I'm going to do this part with whole numbers so we don't have to worry about too many things all at once. Excuse me. So starting with just adding two plain positive numbers obviously is easy. There it is. When you add two numbers that have different signs, negative 5 plus 2, you actually subtract them. 5 minus 2 is 3, but then you keep the number with the sign of the number with the higher absolute value. So 5 is bigger than 2, it's negative, so the answer is negative 3. The next example is actually a lot like the first example. Negative 5 plus negative 2. We're adding two numbers that have the same sign, so you add them and then you just keep the sign. Since they're both negative, the answer is negative. Just like up here, since these were both positive, the answer was positive. Okay, I'm circling nothing, but I think you understand there's implied little positive signs always in front of positive numbers. So. And then this one is a lot more like that one. The signs are different. We have a positive 5 plus a negative 2. The signs are different, so you actually subtract them, 3. And then again, 5 is bigger than 2. It's a positive number, so this answer would be positive 3, or, you know, just 3. So these two sort of go together, and those two sort of go together. And this is, you know, pre-algebra, and you knew this in Algebra 1 and in geometry. For subtracting, most people do not do subtraction. Well, something like this, 5 minus 2, the answer is obviously 3. That's no big deal. But in just about every other case, you've been taught to manipulate the subtraction a little bit, that you change it to like adding the opposite. So for this one, actually, let me move that 2 over. Negative 5 minus 2, you've been probably taught to think of this as negative 5 plus negative 2. And then now that they're the same sign, you add them and keep the sign, negative 7. Here, 5 minus minus 2, you changed it from minus minus to plus plus. 5 plus 2 is 7. And again, from minus minus to plus plus, different sign, subtract, keep the sign of the bigger number, negative 3. So we go up to here, 5 minus 2, something you've been able to do since first grade or maybe kindergarten. You actually can follow the same rule, change this to plus the opposite. 5 plus negative 2, the signs are different, you subtract them, keep the sign of the bigger number, the answer is positive 3. So just some fundamentals of algebra and positive and negative numbers or integer math that you're already supposed to know and you've dealt with for about probably 3 years now. All right, let's go to adding and subtracting fractions and mixed numbers. Now before I get too far into this, I want you to look at the work. It was a very, very long worksheet, so what I did is I blacked out a few to make your homework. I like your homework to be as close to 10 problems as possible. Unless they're really difficult, we'd have like 5 or 6 problems, or if it was really easy, you might have 15 to 20 problems. This one I got down to 11 problems. I cut out the ones that I think really were just redundant. So the ones I kept in hopefully aren't redundant. The first 4, well, and number 6 are same denominators. Those should be pretty easy. So I'm just going to go ahead and go right through. 3 halves minus 1 half. Well, the halves go together. So all you got to look at is 3 minus 1. What's 3 minus 1? 2. So 3 halves minus 1 half is 2 halves. Can reduce 2 halves? Yeah, you can divide them both by 2. You get 1 over 1, and then the answer is just 1. 4 and 6 are kind of silly. Okay, what's 1/3 minus 1/3? Well, the rule is you're supposed to do 1 minus 1 over 3, and that's 0 over 3, and then 0 over anything is 0. But obviously, when you subtract something by itself, you get 0. So down here, 1 half minus 1 half equals 0. Now, when it comes to showing your work on problems like these, if you can do them in your head, I don't need to see work. I mean, I just don't. I understand you're not copying answers on problems this easy. If you can just write the answer, that's fine. There'll be plenty of opportunity to show your work later. So yeah, we should be able to move on. Yeah, no problem. So number 8, again, if you really wanted to know how to show your work, here's what you'd do. You put a fraction bar. You'd say, okay, I'm going to do 7 minus 5 on top and put the 6 on the bottom. The common denominator stays put. And then 7 minus 5 is 2. 2 over 6. Then can you reduce a 2 and a 6? Yeah, you can divide them both by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. So that's 1/3. So again, when it comes to showing work, you don't have to draw in every last little thing that I did. If it's super easy, I get it. You just write your answer and move on. If there's a few steps, maybe you'll write a step down. Number 10, these also have the same denominator. So, but before I do anything, I see I have minus minus. So like I reviewed just a minute ago, oops, that changes to plus a positive. So really it's 1/3 plus 5/3. So when you add, you keep the denominator the same. The top is just going to be 1 plus 5. I mean, okay, if you wanted to, you could write 1 plus positive 5 because that's the way it's written there, but most people wouldn't do something like that. 1 plus 5 is 6. And then 6/3, 6 divided by 3 is 2. So there's that answer. Okay, so I'm going to circle my answers. I do appreciate it when you circle your answers, so I should probably do it too. And I haven't really checked my work. So 1, 0, 0, 1/3, and 2. Let's check. 1, 0, 0, 1/3, and 2. So it looks like there's a lot of work. It looks like for you, your first 4 problems. Oh, not that one. Yeah, well, at least 3 of them have common denominators already, so those are going to be fairly quick and easy. One like number 5, I think I'm going to get to, yeah, right down here. So I'm not going to worry about number 5 right now. And then we're starting to get into denominators that aren't like. So let's talk about number 12. Clearly, 7 and 6 are not the same. And in fractions, you have to have the same denominator to add them. So we go through this process of finding a common denominator. And there's a bunch of different ways to do it. And there's terminology involved. So what you're trying to find here is called the least common multiple of 7 and 6. Generally, that's what you want to do. Least common multiple is also the lowest common denominator. So we want a number that both of these divide into. So one thing you can do is, it takes a lot of writing, a lot of work. I'm not going to do it on every problem, but it might explain or help explain in case this is something you're really rusty on. So you count by 7. 7, 14, 21, 28, 35, 42, 49, 56. It goes on and on and on, but a few like that is good. And then count by 6s. 6, 12, 18, 24, 30, 36, oops, not 42. And then I'm going to stop there because you see that 42 appears in both of those lists. That means that 42 is going to be the lowest common denominator. And before I go any further, I see I did make a little mistake. I want to take a second to fix that. This was supposed to be a negative sign. Account for that negative sign by bringing it over. Okay, so anyway, 42 is in both lists, so 42 is the common denominator. Oh, I don't want to do that yet. Now, how did we get here to 42? Well, we multiplied by times 2, times 3, times 4, times 5, times 6. And this one we multiplied times 2, 3, 4, 5, 6, 7, times 7. So let me erase all of this. This one we multiplied by 6, and this one we multiplied by 7. And I'm already breaking a rule of algebra. Times 6 times 7. That means I need to multiply the top times 6 and that top times 7 as well. 10 times 6 is 60. 1 times 7 is 7. Now we can add these together. Of course, when you do a negative plus a positive, the signs are different. You subtract them. 60 minus 7 is 53. And then keep the sign of the bigger number. 60 is bigger than 7, so negative 53 over 42. So that should be our answer. And honestly, the negative sign should be down here level with the fraction bar. But that's an improper fraction. I doubt the answer is going to look that way. Let me scroll down to number 12 and check and see if it's really improper. Oh, they did leave it improper. Oh, because the problem was given with an improper fraction. It's okay to leave your answer that way. That's right. So there it is. So you find a common denominator, and doing that little chart was one way to do it. Now you might look at this and say, well, you multiplied this one by 6, and that was a 6. You multiplied this one by 7, and that one was a 7. Why don't you just multiply those together every time? That will work every time, but it won't always give you the lowest common denominator. So if you don't have the lowest common denominator, that means you're working with higher numbers. These numbers will be higher, and then your final answer will probably have to be reduced in order for that to work out. But if you don't want to make that little chart that I made of, 14, 21, 28, blah, blah, blah. If you don't want to do that little chart, you can just multiply the numbers together. That will work. But yeah, like I said, sometimes it gives you higher numbers that are harder to work with, and you have to reduce your answer. All right, let's look at number 14. So we've talked about this yesterday. If you have a whole number, its denominator is always 1. So now we need a common factor, common denominator for 1 and 8. So the goal is, can you think of a number that 1 and 8 will both divide into? And it should be pretty easy. The answer is 8. But if you need to, let's count by ones. 2, 3, 4, 5, 6, 7, 8. Let's count by 8s. 8, 16. Wait, too much. We already have a common denominator right there. So instead of going through that whole charade, let's just do this. So we have this fraction minus this fraction, and we determine that the common denominator has to be 8. Well, this fraction doesn't have to change. It's already got an 8. The only fraction we have to change is this one. So this one, we multiplied the bottom times 8. 1 times 8 is 8, so we got to multiply the top by 8. And we're looking at 16/8 minus 13/8. What is 16 minus 13? That's just 3. Oops. And then the denominator, the common denominator, is 8. You leave it 8. So positive 3/8 should be our answer. And there it is. Okay, well, I guess I'm doing check marks here to stay consistent. So let's go down to this problem here. Okay, so a couple things going on. We do need to find a common denominator for 3 and 2. Also, we have minus a minus, so I'm going to go ahead and just change that to plus plus right now. So when I rewrite this fraction problem, it's going to be negative fraction plus fraction. That's what I'm looking at here. So that I'll make that a little smaller so it looks more like a negative sign. All right, so common denominator for 3 and 2. So think it through. 6. You should be saying 6. You could just multiply 3 and 2 together. That works. Oops, I need to erase that. If you needed to count by 3s, 3, 6, 9, 12, blah, blah, blah. 2, 4, 6, 8, blah, blah, blah. But then you see, oh, here's a 6, here's a 6. There you go. So our common denominators need to both be 6. How do you change a 3 into a 6? Multiply it by 2. So you got to multiply the top by 2. 4 times 2 is 8. How do you change a 2 into a 6? You multiply by 3. So multiply the top by 3. 3 times 3 is 9. Now that we've got this, we can find our answer. Of course, it's going to go over 6, the common denominator. Notice we have a negative plus a positive, so you want to think of this. Here, I'll write it down. I did this in my head in the last problem. I'll write it down this one. So think of this as negative 8 plus a positive 9. Negative 8 plus 9 is positive 1. 1/6 should be the answer. Scroll down number 16. And there it is. Okay, so like I said before, if you get it, if you're good to go, you can stop the video and just hit the assignment if you want. If you're having trouble or you need a little more examples, stick with it. I'm going to do 18, 20, 22. And you can see they get a little more harder as I go. All right, number 18. All right, so They do have common denominators, which is nice, but we have mixed numbers. So I'm going to do that process where we convert these to improper fractions. So let me set up sort of a framework over here. I have a negative fraction minus another fraction. 3 times 5, or 5 times 3 is 15. 15 plus 3 is 18 fifths. 5 times 4 times is 20. 20 plus 2 is 22 fifths. Now I can put this all over fifths, and I'm looking at negative 18 minus 22, or negative 18 plus negative 22. When they're the same signs, you actually add them. 18 plus 22 is 30, 40, and they're both negative, so that stays negative. Now we have negative 40 fifths, and it turns out that this is divisible. 40 divided by 5 is 8 with no remainder. And since there is a negative sign here, negative 40 fifths just works out to be negative 8. Let me scroll down and look at 18. It's a lot of scrolling. There it is, negative 8. Okay, I just realized something. Well, hold on. I want to take a peek at this and this. Okay, so in my examples, these are all common denominators, and those are easy. And I didn't want to just do easy ones for examples and then give you hard ones for homework. So I am going to black out well, shoot, give me a second here. I'm going to go ahead and black this one out. I'll do number 20, but I'll also do, let's say, number 26, because they're not common denominators, and we want to look at one that's going to, like, if you can follow along with 26, it's going to help you with 25, because they're real similar. So there, all right, little change on the fly. Okay, so number 20, again, I'm going to do times plus and make this improper fraction, plus negative, another one that I'll turn into an improper fraction. 7 times 1 is 7. 7 plus 2 is 9 sevenths. 7 times 3 is 21. 21 plus 4 is 25 sevenths. So what I'm looking at here, both over 7, it's 9 plus negative 25. We have a positive number plus a negative number, so you subtract. 25 minus 9 is 16. Keep the sign of the bigger number, negative 16. Negative 16 sevenths. Now, that's probably not the answer because the problem had mixed numbers. I bet we need the answer to also be a mixed number. Number 20, yeah, we want that as an answer. So we have to do just a little bit more here. Let me come off to the side. What is 16 divided by 7? Well, 7 times 2 is 14, which is close to 16. Subtract that, there's 2 left over. So I've got a negative sign. That's got to go in my answer. 2 is my whole number. This 2 is my numerator, and that 7 is my denominator. And there's the answer, negative 2 and 2 sevenths that we saw right down here. Okay, so I'm skipping the next 2, and we're going to go right to 26. This will be the last example. So we have mixed numbers and unlike denominators. The first thing I need to do is make them improper. So I've got, well, let me move this over a little bit. There's a negative sign there. So negative fraction minus another fraction. 8 times 3 is 24. 24 plus 5 is 29 eighths. 5 times 4 is 20. 20 plus 2 is 22 fifths. And let me make that 9 more clearly, a 9. So now we need to find a common denominator for 8 and 5. And we can just multiply them together again if we want to. 8 times 5 is 40. 40 is going to be a common denominator. So negative fraction over 40 minus fraction over 40. This one's times 5, so therefore I have to multiply that times 5. 29 times 5. Well, 30 times 5 is 150. So this got to be 145. This one I have to multiply by 8. 5 times 8 is 40, so I got to multiply that by 8. 22 times 8. And obviously, feel free to grab a calculator. You can have a handheld calculator, or you can split your screen on your iPad and use a calculator if you need to. Anyway, 22 times 8. 20 times 8 is 160. 2 times 8 is 16. So 160 and 16 is 176. Now we have negative 145. Negative 145 minus 176 all over 40. So we're going to change this to, let me make a little space here. Change this to plus the opposite. Both signs are the same, so we add them together. 5 and 6 is 11, carry the 1. 7 and 4 is 11, plus 1 is 12, carry the 1. 1 and 1 and 1 is 3, so negative 321 over 4. And I just bet we need to take 321 divided by 4. 4 won't go into 3, but 4 goes into 32 8 times. So you subtract that, there's nothing left over. Bring down the 1. 4 goes into 1 0 times. So that means 1 is the remainder. So we have a negative sign here. 80 is the whole number. 1 is the numerator. And 4 is the denominator. And that's about as bad as it gets. That was a lot of work for one problem. And again, that's why I scribbled out some of these, because I didn't want to just bury you in busy work. Oh, yeah, okay, there's the answer. I looked at that answer and thought, oh no, I did it wrong. Negative 8 and 1/40. Negative 8 and 1/40. Okay, so your goal now is to do the odd problems, except for the ones that I have scribbled out. Looking back at number 5 is going to be a lot like when I did number 14. You need to put 6 over 1 before you begin. So keep that in mind. But do your best on these. If you have questions, email or post comments and let me know. Otherwise, good luck and have a great